Welcome to lesson number 4 on the trigonometry unit, functions and graphs, lesson number 4. We're going to look at example number 1. So complete the following to solve cosine theta, which is equal to negative 0.5, where theta is greater than or equal to 0 degrees, but less than or equal to 360 degrees. For all these questions, we're going to be solving them in 3 steps. So the first step is we're going to be thinking about which quadrants this angle exists in. And so if we have, so step 1, thinking about the quadrant it exists in, if we have cosine negative 0.5, cosine is negative in the second and the third quadrants. And if we think about what that angle is, negative 0.5, in these lessons, what we're going to be in this lesson, what we're going to be looking at are the inverse cosines. Right? So if we're given the ratio of 0.5 and we want to find and first of all, make sure if we're looking for degrees, we're in degrees. But if I have cosine of 0.5, inverse cosine of 0.5, that would give me a reference angle of 60 degrees. So this is going to be 60 degrees, and 60 degrees in quadrants 2 and 3. But if I have an angle of 60 degrees, and I went cosine negative 1 of 0.5 equals 60 degrees. In quadrant 2, I would go 180 degrees minus 60 degrees. That would give me 120 degrees. And in quadrant 3, I would go 180 degrees. So if this is 180, I know that the difference of this angle from 180, if my reference angle is 60 degrees, will be 120. And in quadrant 3 here, I'm going to be adding my reference angle to 180 degrees to give me this angle of theta, which would be 240 degrees. So theta is equal to 120 degrees and 240 degrees. In example number 2, we have a similar scenario. And again, we're going to have to approach this question by trying to determine which quadrant that this can be in. Now, given that sine theta squared can be written as sine square theta, solve the equation sine square theta equals 0.5. Well, if I have sine square theta is equal to 0.5, I can take the square root of both of these in order to find just sine theta. And I take the square root of this will leave me with the two options of being positive and negative values. And so if they're positive and negative, then, and we're looking for sine where sine is positive and negative, that means that sine is going to be in all of these quadrants. Alright, so sine is going to be in all of these quadrants. And not the best diagram, these angles should all be equal. So inverse sine of 0.5 of, square root of 0.5 equals 45 degrees as a reference angle. So my reference angle is equal to 45 degrees. So 45 degrees in every quadrant. That means in quad 1, I have 0 degrees plus 45 degrees equals 45 degrees. In quadrant 2, I have 180 degrees minus 45 degrees equals 135 degrees. And quad 3, I have 180 degrees plus 45 degrees, which is 225 degrees. And in quadrant 4, I have 360 subtract 45 degrees, and that would leave me with 315 degrees. So those are all the angles given that sine square theta is equal to 0.5. All right, next example we're going to look at is one that involves cotan. So if you look on your calculator, there's no keys for cosecant, secant, or cotangent. And so what you have to do is you have to rewrite it as reciprocal of the primary trig ratio. So if it's cotan, you got to write it as tan. So remember that tan, how should I write this? Tan is, so if I had tan theta, that's equal to y over x, but cotan theta would be equal to x over y. And that's because cotan theta is equal to 1 over tan theta. And so if I have cotan x of the square root of 3, I can rewrite that as 1 over tan over square root of 3. All right, and so if I were to write just tan x, this would be 1 over square root of 3. And it's positive, so it's, remember, if I have a cotangent and tangent, those are going to be positive in the same quadrants. So if it's positive, then it can be positive here, or it can be positive here. So in quadrants 1 and 3. All right, so let's see what the reference angle is going to be there. You can do this in a few different ways, but you can start with going 1 divided by square root of 3. You get 0.577, and now we can go inverse tan of that answer. And I get a reference angle of 30 degrees. So my reference angle is equal to 30 degrees. And remember, it's positive, so it was in quadrants 1 and 3, which means that I have to add my reference angle to 0. So quadrant 1 would be 0 degrees plus 30 degrees gives me 30 degrees. And quadrant 2 was 180 degrees, plus, not quadrant 2, quadrant 3, plus 30 degrees equals 210 degrees. And that was solving for x, and so x is equal to 30 degrees and 210 degrees. All right, let's look at this next example. Class example number 4. Determine the measure of x to the nearest degree where theta, or where x is less than or greater than or equal to 0 degrees, less than or equal to 360 degrees. So secant, remember secant, if we were looking for the cosine of x, would be equal to negative 1 over 1.2631. And we would do the same thing for the cosecant, but so I'll just work on this one. Just remember that you're doing the sine, the reciprocal of the sine for this one. But for this one, we're doing the reciprocal of the cosine. It's negative, and so if we have a negative angle, or a negative ratio for cosine, that means this is in quadrant 2 or 3, since cosine is positive in these two quadrants. So the reference angle here, -1 divided by 1.2631, and the cosine of this is 142.3449. Oh, sorry, and I did negative, so let me redo that. 1.2631. 37. We'll run that to 38. So before I typed in the negative ratio where I should have typed in a positive ratio. So 38 degrees is my reference angle to the nearest degree. So if it's in quadrant 2 and 3, then x is equal to 180 degrees, subtract 38 degrees, and it's also equal to 180 degrees plus 38 degrees. So we'd have 142 degrees and 218 degrees for my value of x. All right, next let's look at we're going to be doing the same thing, but now we're going to be doing this in radians. And so if we're doing it in radians, we do it the same way. We determine the quadrant of the angle by looking at the sine of the ratio. Then we need to determine the reference angle according to 0 and pi over, and the reference angle is always going to be between 0 and pi over 2, or 1/2 pi. And then we determine the rotation angle using our reference angle. All right, so yeah, if you remember the chart that we did, and I think it was lesson 2, it looks something like this. And it's just talking about the difference between the rotation angles and the reference angles and how you actually find the reference angles from the rotation angle. Okay, so let's look at class example number 6. So in each case, determine the value of theta to the nearest hundredth of a radian. All right, so I'm looking for cosine theta of 0.5, and remember the first thing we gotta do is find out where this angle is. So if it's a negative cosine, then that means it's in quadrants 2 and 3 because only sine and tan ratios are positive in these quadrants. We're in radians now, and so if we're in radians, we got to switch back to our radian mode. And if I'm looking for the inverse cosine of 0.5, I just type in the same thing I've typed in before. Now when I do my calculations, I'm going to be using not negative, but 1.047. So we're rounding this to the nearest hundredth. All right, so 1.047 here. That is what I'm going to type in. If I'm looking for the reference angles here, remember that this is pi. And what I typed in to find my reference angle was I converged radians. I went cosine, inverse cosine of 0.5. And I got 1.047. Theta is equal to pi minus my reference angle at 1.047, and I have theta is also equal to pi plus 1.047. So pi minus my reference angle, 2.09, and pi plus my reference angle, I get 4.19. And those are my values for my theta, for my angle. All right, last example we're going to look at is class example number 7. And so I recommend that you read that section, the section up here first. It just walks you through some different ways to use your calculator. And it also kind of explains well the angle measure as an exact multiple of pi radians, which is also helpful. But let's look at this example B where it's using the secants. All right. So again, we approach this by thinking about where is this going to be. It's negative secant, which is the cosine, which is the reciprocal of the cosine. So that means it's in quadrants 2 and 3. So I can also rewrite this as cosine theta is 1 over negative root 2. My reference angle then is going to be 1 divided by root 2, and the inverse is 0.78, which is about 2/3, which is about pi over 4. And angle theta is equal to pi minus my reference angle of pi over 4, and the reference angle the 180 plus pi over 4. And so my angle theta is 3 pi over 4 and 5 pi over 4, and 3 pi over 4 because if I find my common denominator, that's 4 pi over 4 minus pi over 4 is 3 pi over 4. And this would be 4 pi over 4 plus pi over 4, which is 5 pi over 4.